Okay, great. So as Urs was saying, I have 3 jobs. My first job is with eBay. I'm the Senior Director of Global Foundation Services, and that I'm the single throat to choke when it comes to anything around data centers, networking, security, asset lifecycle. I pay the power bill, all those different things, so I'm directly impacted by many of the decisions and the things we talk about today. On the other side, I am the founder and chairman of Data Center Pulse, which is really just a group of industry professionals, end users, coming together to try and hopefully influence the industry on what we need next. The other part is I'm now on the advisory council for the Green Grid, and just became the vice chair, I think it is. So more work. Thank you very much, Mark. But I think that all 3 of those things are extremely important. And the whole theme of this is to share. And to share is to go back and gain knowledge. Everyone can hear, look at information, and decide what they want to do with it. At the same time, they can give information out for others to utilize. And my whole conversation in this is about what we've learned so far. So there may not be specific best practices that we're talking about with one use case, but I just wanted to share what my thoughts are on where I believe we are going, and also what the potential is, and what has worked for us. And you can apply this again, of course, across your own data centers and your own fields to see if something would be applicable. Okay, so first, let me give you a baseline for, yes, next slide. So let me give you a baseline of what eBay is and why my throat is choked a lot. So we are about 2 billion page views a day. Okay, there's 23 million lines of source code that we've got underneath eBay.com. On top of it, we've got 260 million plus active listings, or things for sale on the site in a given second, and that continues to grow. 75 billion database calls a day, and that is 4 times, I think, the quantity of the New York Stock Exchange trades. The other side of that is we have greater than 50 petabytes worth of storage. More than that, and I'll share a little bit later with that. But all this rolls up into $62 billion worth of transactions a year. That's gross merchandise value. That's actually exchanged between buyers and sellers on the site. Okay, so it is the world's largest online marketplace. Okay, we are our own little economy. And the interesting part is this is growing like mad. So this is $4 billion of that $62 billion already. Next slide. So you can see that we own a number of companies as well. 94 million active users, okay, so that's registered every month, people that are doing something. Millions at every given second are doing transactions on the site. We're in 190 different markets and in 24 different currencies. And of course, PayPal is one of our largest companies, and that completes the entire transaction. But also StubHub, Shopping.com, Half.com, Rent.com, Marketplace when it comes to classifieds all across Europe and in Asia. So a lot of companies. Next slide. And so, next slide, thank you. I wanted to talk about the business demand, what keeps me up at night. These are the things that make us have to continuously keep on our toes. So PayPal, growing 25% year over year, continuously growing. It is amazing how much transaction volume happens through there. And as I was saying, mobile is quadrupled in less than 2 years. So we put out the eBay app, it went into the iPad, and it went to 500 million like that, and it's now gone up 4 times from that. And that is changing the way people shop. Doesn't matter if it's us or others. People are starting to buy anything, anywhere, however they want to buy it. And that will continue to expand. On top of it, we've gone from 140 million listings or items for sale to 260 in less than 3 years. So a ton of people are taking advantage of the site. And ironically, it doesn't matter what it means to the economy. A lot of people are looking for deals, so whether it's up or down, we've got just volume of activity that continues to increase. On top of it, we're deploying a brand new search engine, okay, in parallel. So it's a very large implementation to go back and roll up very quickly. On top of that, data has grown over 500%. Data is king. Data is going to drive everything. If you don't understand it, start to learn about data. Hadoop is a massive, massive movement right now, because once you understand what your customers do, through the data that they actually generate, you will actually give them what they're looking for to buy, and you will uplift your revenue. We've proven it already. On top of that, we're going to be refreshing at least half of our equipment this year. Half of our equipment. We have a 2-year tech refresh. We move that because we get double the performance for half the power costs, and we compress everything else, as well as we lower the overall consumption of the power within the data center. But even with that, all these things are adding up. Our forecasts look like we're going to be doubling our power consumption in 5 years. I pay the power bill. I'm half of the operating costs for the company when it comes to the largest thing, which is operations. And that, by the way, also is half of the carbon footprint. So I have a responsibility to the stakeholders, the shareholders, as well as the planet to ensure that we're doing everything we possibly can to be as efficient as possible to balance both of those sides of the scale. Next slide. So the way we've done it in the past cannot be sustained and doesn't keep us competitive. We've got to do something different. And this has been really, I've been at the company almost 2 years now, and the first thing I came in and saw was great opportunity. They'd done some really good things, but we could take it even further. So I was really excited about this position. So next slide. Now, let's go into what we've learned. Again, this is what works for us. You can apply it however it works for you as well. Next slide. I wanted to go into the specifics. First thing I saw when I walked into the company was we had a great big Tier 4 bucket. Everything was in Tier 4. Very expensive bucket, okay? So we decided that we really need to filter through what workload, what services, what are we doing, and what resiliency do they really require. So one of the big things that I love about this job is we are an organization that has everybody in it. So we're all under the same goals. So that's the IT side and the facilities, all working together with the same budget, the same efficiencies, the same margins, the same everything we have to keep under control. So it is a holistic look at it. So I can do this kind of right size application thing with my partners. So what applications you have with product development, et cetera. For example, search doesn't need to be in a Tier 4. It's search. You pointed out a different data center. Databases, network backbones, all those components, those need to be in a Tier 4. But when you break it down, about 80%, up to 80% of our equipment could live in Tier 2. Yet it's all in Tier 4. Okay? The outline, or the bottom line of that, is we can cut our CapEx in half and our OpEx in half when we right-size these applications. There's real numbers underneath because I pay those bills. The other part is we had so many SKUs of servers. We had all these different groups buying all this different type of equipment. Really inefficient, really expensive. Contract negotiations are really, really difficult because everybody's buying their individual things. So we collapsed. 80% of our equipment, we collapsed into 2 SKUs. And we had to do this into 2 pieces. Hadoop, okay? Hadoop is very data intensive, of course, and they have to have local storage on them until someone solves that problem. But we've got now a server with 24 terabytes of storage per node, okay? So that's a Hadoop configuration. Then the other one is everything else. Same server, same memory, same network, same everything, all those components. And that satisfies the majority of stuff that we're actually purchasing. That happens to be the tech refresh that we do at a 2-year cycle. It happens to be the growth, the new search engine, the Hadoop deployments. All of those components we've got a service for our customers. On top of that, when you look at it, so I'm right-sizing my applications, I'm looking at the smaller number of SKUs. Well, what does it truly cost me to operate? This is extremely important and been really, really effective for us. Holistic TCO model. We're literally looking at every cost it comes down to deploy an application on that equipment, end to end. So it changes the buying decisions. When I know that server is going to cost me this much money in its useful life with this standard workload over that period. Okay? So the next part is a comprehensive RFP process. And I love this because people have been coming out with new things like the Facebook stuff that came out. Right, they're building their own servers, and they've got a huge volume, and I'm sure it's working great for them. What I've found on our side is when we put out a competitive RFP and we engage all of the groups outside to say who wants to participate, that's when we get the innovation, that's when we get the creative thinking. They come back with solutions we may not have thought of. And we also award to the companies where we get the extension of their engineering teams. We get all of their resources behind us like we'd own our own. So for us, it's worked really well. I've gotten to a price point that's been incredible, as well as they're developing new things for us because we're buying that equipment and refreshing those cycles. It also drives greater efficiency, and I'll go into the TCO model here in just a second about that, because now I can truly see how well this server compares to a competitor over its useful life. That is really the holy grail when you look at it. How do I ensure I'm getting the maximum benefit out of that choice of hardware? So, and it also enables the future. I'll go that into a second. Next slide. So I had to take out some of the dollars in here so I don't get fired. And so there's, this is the density analysis. This is where a couple of us differ in the industry. I love density, okay? And I'll explain a little bit further why. If you look at this, this is the all-in cost for the data center to deploy 2,000 servers for doing search type workload, which is latency dependent on the frequency of the CPU. I can't do slower CPU things without decreasing the search results themselves. But we did the analysis to figure out what it would look like. We had a lot of people saying, well, instead of buying 2,000 servers, why don't you just buy a whole bunch of cheap ones, right? The smallest CPU frequency you can get, the lowest wattage, which is the right thinking because I should be able to consume less. The problem is I still have to do the same amount of workload. So 2,000 servers. If you start from the left, there's 4 columns. The third one is the baseline. If you look at it, 2,000 servers at 2.93 gigahertz, 6 core. Okay, Westmere type processors from Intel. If I get 2,000 of those and I put it into 14 kilowatt cabinets, that's the red line. If you go up, okay, that's the all-in cost. The green line below is if I happen to collapse them into 28 kilowatt cabinets. It's lower. Why? Because I don't have as much infrastructure. I don't have as many footprints. Okay? As I start to expand out, you can see if I said, well, I want to do the same amount of workload with a 2.26 gig proc. Well, that's going to lower my cost of the server itself, right? Because the CPUs will be cheaper, et cetera. But I'm getting more of them. I need 2,593 to do the same workload as 2,000. All right? Same thing goes to the 1.6. And you can see that curve. And a picture starts to come out. There's a sweet spot right in the middle there at that frequency for that type of workload. By the way, that happens to be everything else, not Hadoop. All the other hardware. Okay? So that's great when it comes to the data center. But we need to look at it holistically. So the next slide. This is with everything, including the servers, the depreciation of the servers, the software that's added onto it, all those components. It starts to level off, but it's the same thing. If you look at it, it still is most cost effective for me to deploy density, because this is supply chain. This is full cost. This is the RFP results that we can get back these really low costs when we have that density formula. On top of it, if you look at the right side, well, let's go the other way. Why wouldn't I increase the frequency even higher and go to 3 gigahertz, 3.4 gigahertz processors? The issue, you're paying a major premium for that CPU, okay? And it doesn't work out. I'm still consuming more power because you also have more wattage for that CPU. So the bottom line here is that we found that density, finding the right performance piece for every one of these refresh cycles we're doing, gets us major savings when we're looking at the whole cost of ownership for deploying hardware underneath into a center that's servicing a certain type of application for our business. Okay, next slide. So, as you can see, density is really important to me, all right? Because we've proven that inside for us that it works. And as I said, there's 2 of the configurations. It's 48 servers in a cabinet. That's for the Hadoop, okay? It's up to 17 kilowatts. And that's 24 terabytes per node, et cetera. And it's 3,500 pounds. I don't know what that works out in kilos, but it's a lot. It's a big car. And that's another component in it. It's the power, the cooling, the data center networking itself inside of the cabinets to the actual weight. All those have to go together into a sweet spot from a cost and a deployment management standpoint. Everything else, the other SKU, is 96 servers per cabinet. So interestingly enough, so the half-use servers like Microsoft and others have been looking at, we're deploying those as well. And this comes down to a same 48U cabinet with 96 servers. That works out with 4 switches. They have now the port counts matched to those. Plus we've got 14 gig uplinks. We almost line rate to everything, so we can just do it very quickly. And as you saw, greater than 20 kilowatts is cheaper for me to deploy than it is for 14 kilowatts. You would think that wouldn't be that way, but that's the reality of it. On top of it, we have rack and roll now. We're outsourcing all of this into the RFP responders. I don't want a rack, stack, cable, image, everything else. I want you to give me a cabinet with that SKU, image to this level, that I roll in, plug the power in, plug in the data, and provision. Now I can take my supply chain, and if you look at it, cache on demand, now I've just got triggers in my system to say when I need more hardware. And since I've got the server SKUs consolidated, it doesn't matter because whether I'm doing tech refresh on this application or a new search engine or something else, it's the same stuff. And at the same time, I can now roll out an RFP to anybody. You know the spec, what's the price performance you get from me, and the wattage consumed for that workload. Excellent. I now have the power of the community, the industry, to give back the solutions we have because we simplified the infrastructure and the model. The other part is single rack deployments. Now I can do one rack, or I can do modules, containers as people say them, but not the container size, a little bigger, a little longer. The whole point is it's modules of big bulks of server. Like a new search engine, I'm landing 2,000 servers at a time. For the other ones, I'm rolling 96 in. For Hadoop, I'm rolling 48 in. So I can now go on either end of those spectrums. Modular data center design works. We've heard about this out there. And if you look at it, we're doing multi-tier. We're augmenting our tier 4 centers to have a tier 2 capable, or multi-tier, tier 1 to tier 3 choices for us. At the same time, we're doing that in 2 megawatt chunks, so we can continue to expand, extremely efficient, right? PUEs that are going to be amazing. I can't wait to share in October. And then we've also now designed multi-cooling loops. So this is important, is to be able to have a hot water cooling loop. We keep talking about the chips and trying to get the temperatures up. I can now have 87 Fahrenheit, or I believe it's 30.5 C, to the cooling units, okay? Because we're taking two variables here, the outside air temperature and the CPU temperature, balancing to those two. I want the maximum cooling I can get wherever I'm at, so start at that temperature. That's cold for the chip. Okay, and of course know the limits of air cooling. Let's go to the next slide. I believe that the maximum for density in cabinets we've found so far is 28 kilowatts a cabinet. Packed into a smaller space is where the theoretical maximum of air is going to be there. You just can't move enough air over that hardware to be able to cool it. It will start to overheat over time if you're sustaining those loads. So, holistic compute engineering. Remove the massive compounded overcompensation of cooling. If you start really following that chain from the chip and how much they buffer, and then the server, and how much they buffer, and then the data center, how much they buffer, and then the chiller plant and everything else, there's just a massive amount of waste of cooling inside of it. We baby these servers, they don't need to be babied. We can make them hotter, we can make them more efficient as long as you have a holistic view of the data center. Okay, we talked about the server and then the fans going up when the temperature's going up. You have to balance all of that. On top of it, the two variables I talked about. And then horizontal and vertical scale for us. I want to be able to create a highway of 2 lanes and expand it to 12 when I need it, and then shrink it back. So that's like 2 cabinets to 12 cabinets when I need it, when the workload's there, and move it back. That's literally just taking equipment offline. Then vertical scale is to be able to give a gas pedal and increase the frequency and the performance of those servers when I need it, or decrease them. For example, Hadoop, we're buying 2.4 gigahertz processors. We're downclocking all of them to 1.6 day one. Why? Because that lowers a huge amount of wattage, and it gives me runway. As they optimize the code and take advantage of it, the utilization goes up, I just step up the frequency. I've given myself 2 more years of runway in that hardware. Okay? The infrastructure convergence, when it comes to the data center and the IT, those have got to be together to truly have a look into the whole machine itself. You've got to have that. Overclocking, I love it. Liquid cooling, I love it. It's what's next. It's what's going to give us the performance we're looking for. We're going to drive that, and hopefully the industry is going to be adopting some of those too. But it comes down to the manufacturers have got to solve this problem. We're working directly with them because it's about performance and cost. And I will get the efficiency if I can tune to those 2 variables, the chip and the outside temp. And if I can now have the liquid directly to those chips and I can get that workload, I can cut the amount of servers I'm buying. And the overall TCO suddenly makes my number of cost per megawatt continue to go down. Okay, we want to create a tuned engine. If you go to the next slide, it's all about a gas pedal. We want to be able to have a car that can go like a Prius, that can accelerate to a Ferrari, and back off when you need it again. Because that's the nature of the business. The workload goes like this. So why wouldn't you have an engine that tunes to it? Just like I'm using electricity or gas when I need it. Why wouldn't I create a data center that gives me that capability? Okay, it's all about performance, cost, and efficiency when those all come together. Next slide. Here's an example. That is Cassini. That's our new search engine. That's 96 servers. It was just deployed out in Las Vegas. It goes towards the 25 kilowatt plus when it's under load, right? It is 3,000 pounds, and they roll right into the data center, and we got them hot within a couple hours. Hours. Love it. Next slide. The next-gen data center for us. This is Phoenix, Arizona. We're building a Tier 2 facility right adjacent to our Tier 4 facility, as you see on the right side over there. This is going to have the capability of 4 megawatts day one, 14,000 square feet, 1,400 square meters, I believe. 4 megawatts scalable to 6, and even higher that. I don't want to share what it's going to be. But we built the infrastructure to say what's the max we can get that's tuned to the density that's coming, so that we've got useful life runway for that data center. This is the one that has hot air cooling, or hot water cooling capable. So I can plug into a cooling unit that's in row with the server. I can plug into a rear door passive cooling heat exchanger, or I can do direct to the server itself. The point is the data center is generic. I've got the ability to say 55-degree water or 87, and then optimize over time the solutions that we're actually deploying. And with that, any questions? Just trying to dump out a lot of information quickly here. Get us on track. Hey, look at that. I saved you 4 seconds, Paolo. So, any questions? Am I out of my mind? Mark thinks I am. It usually happens.
Yes, but that's not a question.
Yeah.
Hey, could you go into more detail on the, I think you said 30.5 C water?
Yeah. So we're deploying both containers and rack and roll, so and racks inside of the data center. So we went back and looked in the thermal or the actual environmental conditions inside of Phoenix and said our starting point will be the hottest day of the year in Phoenix, which even though it's 130 degrees outside Fahrenheit, it's 87 Fahrenheit that we have to cool because it's so dry. So start with that. I want supply water there as what people should be designing to. So then it just gets easier from that point. So they've designed the infrastructure to be able to deliver tower water that way, right? And so 30.5 C is kind of the max, but all the other times we just get even more efficiency because it's cooler. Does that make sense?
Yeah, it's interesting because we were looking at using a river adjacent to our site. Sometimes in some of the water is 22, 23 degrees.
Yeah.
That seems to be a problem.
It's freezing.
Well, that seems to be a problem for some of the in-row cooling vendors we were talking to. So that was eye-opening, 30.
Mm-hmm. Well, let me give you 2 things. Okay, first off, the server manufacturers, they will warranty the hardware at these higher temperatures. Ask any of the larger players that have pushed these folks, right? I've got warranty containers that are going to have hot water cooling directly to them, giving me free cooling year-round in Arizona, day 1. I've got that coming. It'll land in July, and we're going to share it with the industry in October because you can. So what we've done is you've got the 2 loops. Just think of it, there's a heat exchanger. Not mixing the loops, you can't do that. But you can now say, well, for say 4 or 5 hours of the year, it's just too hot. Well, then use the 55 loop to actually cool down part of the 87 loop to make sure you're staying within those parameters. But that's simple and easy, right? Exchangers are there. Container while it's in, plug it into the same exchanger, and you've got to have that infrastructure to support it. Okay? Now on the cooling side, inside of that container, the manufacturer's tuned it all. They've warrantied everything. It's a box that lands that they handle. That's it. On the cooling side inside, there are manufacturers here, Liebert, Knurr, all the different companies. They can do higher temperatures on those units. You do lose some of the capacity, but as I found, that range continues to just follow. If you're starting at this point, as long as your other temperature point is higher, it's not like this. It moves up that spectrum. So push them. You can. It works. They deliver. Any other questions?
Yeah, Dean. Tom Raftery from Red Monk.
Yes.
Just a very simple question, and you've partly answered it already, I think. But Arizona doesn't seem like a very intuitive place to be building a data center. Surely there are better places. Why Arizona?
So the company had actually invested in the portfolio already. So we had Arizona, and then from there, we're latency bound, right? Our application is very, very specific, and so we've got a radius of how far we can go within the networking connectivity that we had to choose our locations. So we've basically created 3, and I've put 2 in a desert, right, and 1 in Utah. So we've got Las Vegas, we have Phoenix, and Salt Lake City, because they all meet the latency requirements, and then we're tuning inside of that. Right? We're also working on all of the sustainable energy, right? Clean energy, et cetera. Very difficult to solve in those areas, but I'm bound where I'm located. So we're working with the government. We're working with the utilities and everything to truly influence how we can get clean power in those regions. And I wish the U.S. would just look at Europe. Geez, you guys solved this 20 years ago. Right? I can get clean power in Luxembourg, in Sweden, everywhere. So, frustrating. Any other questions, or am I?
We're running out of time,
Okay.
so thank you, Dean,
Great.
for your presentation. You're going to stick around a little bit, so catch
Yes.
him as you see him here. So thanks, Dean.
Thank you.